Okay, so I apologize for not saying that, but yeah, that gives you information on the grains. And as many of you may know, Vittorio Violati and his team found when they did materials analysis on this scale and then ran materials, that when they had 100 faces on the surface, they were more likely to get excess heat than if they had 110 or 111 faces. Okay, so that's why we're interested in the what's called the texture from the metallurgical viewpoint.
The difference in texture may be due to the fact that you rolled or your ingot before annealing it, okay?
Yeah, so
when you make a rolling in annealing, you get such a new structure.
Yeah. So if we cook the material at 650 C for 2 hours, Imam determined many years ago that you will anneal out dislocations and soften the material. If you go to 800 C for 2 hours, then you get grain growth. So we could anneal, vacuum, or anneal in a argon atmosphere the material, the new material on the right, to achieve something like that. So we have some considerable knowledge of what to do in that regard. But right out of the box, this is what we found with the materials.
And mechanical working before annealing is important.
Hello, my name is Solon from Swiss Toxic Hydrogen. I just want to make a small comment. I was working with the electrolyzers for a long time. One of the elements what took account in is the bubbles. You were talking about bubbles. If you have a lot of bubbles on the electro wire, it changed the resistivity, so you have to get rid of it to put, water pump or something that to remove all the bubbles from the wires.
Yeah, I appreciate that comment. We have measured for galvanostatic conditions the variation in the voltage due to bubbles, or more, if you apply voltage, if you have a bubble on the surface, there's a dip in the current. Okay, so we have seen that in some nickel hydrogen runs that's been analyzed by colleagues of mine in Switzerland, and we know that, but I don't know a way to stop it. So I'm going to be wanting to talk to you in detail about how to do that, because clearly the bubbles are good news and bad news. Good news is they stir the electrolyte, they lead to isothermal conditions inside the test tube, but they do block the cathode. So thank you.
Wait.
Yes, my question is, how many watts do you need to get to boiling?
How many watts do we need to get to boiling? We don't know. We haven't run it to boiling yet, but we've run it to 85 C with about 16 watts.
Yeah, because it carries 2 cells and 10 watts to get to boiling. Because the less watt you put, the better precision you get in the final results, obviously.
Yes, and when you look at calorimeters across the field here, this is not a high-performing calorimeter, but it will be adequate for what we need. But if you say the Icarus calorimeters could boil at 10 watts, and I'm saying that we only got to 85 C, with almost twice that, then it's a measure of the difference between those two calorimeters. Yeah, thank you.
Did you analyze with high position, for example, like with ICP-MS bulk material to see if there are some composition variations?
Yeah, we have gotten glow discharge mass spectroscopy done already, and I didn't present the data for reasons of time, and it's difficult to get a grasp of it in a short time, but we have that data, and we're going to do considerably much more chemical analysis on these materials. Thank you.
Could such palladium boron alloys be provided to other laboratories?
Our hope is that we will get excess heat, that is, we will verify in the current phase 1 program what Mel Miles has seen, and at that point provide everything to 6 major laboratories, materials included, everything. So some of you may be sitting there, gee whiz, if this succeeds, I'd like one of these systems. Well, we will have a deal for you. We will provide you, as I said, the equipment, the software, the materials, data analysis, on a contract basis. You run our protocol on our time scale. Okay, we'll have a contract with you. So we are hoping that we will see excess heat. We'll have a defendable basis for getting additional funding to clone the setup and then to interact with several major laboratories. Thanks.
So, thank you very much.
Okay.